Welcome, everybody. Now that we're pretty well acquainted with our systems of linear equations, we are going to dive a little bit deeper into this topic and actually come up with those systems ourselves based on the scenario that they represent. So we are going to explore some practical problem solving using systems. Be sure that you have Desmos ready to go. How do we do this? I broke it down into 4 steps. The first step, generally, when solving a math problem, is making sure that you know what the question is asking you to find. Step 2 comes directly after that and comes from it. Once we know what we're asked to find, we can then let those items be our variables. So we're going to be very particular when we are labeling and defining our variables. Step 3 is probably the hardest step. Set up the equations. We're essentially taking the scenario written out in words and we're transforming it into math equations. And then lastly, step 4, I think, is the easiest one. We're just going to plug those equations right in and see where that intersection point is. That's how we solve a system. Let's do some examples with this 4-step process. Maria sold roses and daffodils. She sold a total of 50 flowers. She sold 10 fewer roses than daffodils. How many roses and daffodils did Maria sell? Well, step 1. What is the question asking us to find? The question is asking us to find how many roses and then how many daffodils. So number of roses and number of daffodils. After answering that, we can see clearly how we can come up with our variables here. So because what we're asked to find is the number of roses and the number of daffodils, we're going to let x equal number of roses. We're then going to let y equal number of daffodils. If you want to use other variables, feel free. However, this is the way that Desmos will speak and will be the easiest when finding our coordinate points, knowing which is x and which is y. So I'm going to use x and y throughout this video. Now, step 3 is probably the hardest part, but we got this. Let's take a look at the 2 sentences in here that really are helping us come up with these equations. Since x is number of roses and y is number of daffodils, we can see that we have a total of 50 roses and daffodils, i.e. flowers. So total means we're going to add our 2 values together, x and y. So our next equation is going to be x plus y, roses plus daffodils, equals or is 50. Now, the next sentence is going to allow us to come up with our next equation. There are 10 fewer roses than daffodils. So if we take the number of daffodils and subtract 10, we get that smaller value of roses. Or roses is daffodils minus 10. Now, what if you swapped these 2 accidentally and did y equals x minus 10? It's actually okay in this situation. We might just have the x and y mixed up, but we know that the number of roses needs to be the smaller value in the end. So here is our system. And now what we can do is we can go over to Desmos and just graph it just like that. So we have x plus y is 50. That is a line in standard form. And I'll move this around so we can see the line. Then we have x equals y minus 10. I can see part of that. All right, let's zoom out a bit to get our bearings. And there we have it. This system has one solution. It's 20, 30. So we can see here, and I've snipped our solution here. 20, 30 is our solution. How do we actually answer that? Because it's asking us to find. So we're going to go back to step 1. What is the question asking us to find? And I guess we could argue that step 5 is answer the question. But she sold how many roses? Roses is x. It goes 20, 30. So roses is the 20. So she sold 20 roses and 30 is y. So she sold 20 roses and 30 daffodils. Does that answer make sense? Does that total 50? Yeah. Are there 10 fewer roses than daffodils? Yes. Second example. We see here that we want to find, so this one's a little bit trickier. Kind of sounds like a riddle. Find the value of 2 integers that have a sum of 35 and a difference of 7. Find the value of two integers or two numbers. In this case, I'm being specific, integers, so no decimals or anything. They have a sum of 35 and a difference of 7. All right, what is the question asking us to find? The question is asking us to find two integers. Then that's going to allow us to label and define our variables. So the question's asking us to find two integers. So I am labeling x as the first integer and y as the second integer or number. Now we want to set up the two equations. We see that we have some math keywords in here. We have sum and we have difference. Remember, sum means to add together. Difference means to subtract. So we see that our sum is 35. That means when we add our two numbers together, we're going to have x plus y equals 35. That's our sum equation. X plus y equals 35. How about our difference equation? The difference of 7 means that when we subtract the two numbers, we get 7. That would also mean that if we subtract the numbers in another way, we could have gotten -7, just depending on the order that we subtract them in. I am just allowing x to be the larger number. Let's go ahead and graph these. So we'll have x plus y equals 35. So that's a line written in standard form. So is this. X minus y is 7. Taking a look, we can see that the system also has one solution, and it's at 21, 14. So what does that mean for our answer? That means that one of our numbers, x, is 21, and the other number is 14. So answering our question here, the numbers are 21 and 14. In this case, the order that we write these two numbers doesn't matter. They sum to 35, and when we subtract them, we do get 7. Okay, example C. All about Girl Scouts. And I looked up the price of Girl Scout cookies, and I'm only fibbed a little bit that they were different prices, but for the sake of the problem, here we go. So we have our troop is selling Girl Scout cookies, but the individual box sales for Thin Mints, yum, and Tagalongs, yum, got mixed up. Your troop has sold a total of 163 total boxes, a lot of word total there, of the two types. Thin Mints, $6 a box. That's actually true. And Tagalongs, $5 a box. It's actually $6 in the real world, but that's okay. Sales totaled $900. How many of each box were sold? This one's a little bit trickier, but again, we know that this is a systems problem because we got two things that we're being asked to find. And however many variables you have in math, you need that many equations. So we're asked to find two things. What is that? Number of boxes of Thin Mints, number of boxes of Tagalongs. Those are the things we're asked to find, the number of boxes of each. So that allows us to come up with our variables pretty easily. I just made the phrase shorter in step 2, but basically X is boxes of Thin Mints, Y is the boxes of Tagalongs. Now we're going to set up those two equations. Take a look at the information that's given to us in this problem. We see that word total was accidentally used 2 times, but we have a total of 163 boxes of the two types of cookies. That means when we add our boxes of Thin Mints and our boxes of Tagalongs, it totals 163. Do you know what that equation would be? X plus Y equals 163. The total equations just mean add together and set it equal to that total. Next, we're going to have some coefficients in the mix here. We see that this next equation has to do with money, and we again have a total. So I'll use green for money. Thin Mints are $6 a box. Tagalongs are $5 a box, and all that money totaled $900. So I know that when I add two terms together again, I'm going to get 900. But instead of adding X plus Y, we can't just do that now. X plus Y is how many boxes were sold. This is money, and we have to multiply the cost per box by how many boxes. Thin Mints are $6 a box. So we sold, or we raised $6 times the boxes of Thin Mints. So $6 per box times how many boxes there were is total money for Thin Mints, 6x. Think about what the next term would be. 5y. Tagalongs or y are $5 a box. And now that totaled 900. Let's solve this by graphing. We have our system here. We have x plus y equals 163. 6x plus 5y equals 900. Now these numbers are big, so we're going to probably have to zoom out quite a bit. We notice here that these two lines actually both have a negative slope. In our other examples, the lines looked more like an X, but these are kind of going like in the same way, but that's okay. They still intersect. Desmos will automatically find that intersection point. We know that our answer has to be integer values because it's number of boxes of something. So we couldn't get like decimals here. All right, so we see that our solution is 8578. So looking at this next page here, we had our two lines for our system. Here's our answer. So let's answer the question. 85 is the number for X. X was Thin Mints. So there were 85 boxes of Thin Mints sold. And the other number 78, that's Y. Y is Tagalongs. 78 boxes of Tagalongs sold. And there we have it. There is our answer. Okay, our final example today. Northern Heights High School is selling tickets to the winter concert. On Monday, the school sold 3 adult tickets and 1 child ticket for a total of $38. On Tuesday, the school took in $68 by selling 5 adult tickets and 2 child tickets. What is the price of each ticket? This question is asking us to find the price of each ticket. So price of adult ticket, price of child ticket. Boom. Those are our 2 variables. So X is going to equal the price of the adult ticket. Y is the price of the child ticket. Let's take a look. We kind of have 2 scenarios again here. We have 3 adult tickets plus 1 child ticket totals 38. So X is the price of the adult ticket, and we sold 3 of them. That's going to be $3, or rather, sorry, 3 tickets times how many dollars each one cost for adult. What would the term be for child? 1 child ticket, so 1 Y, or just Y. And that's going to total $38. Think about what your next equation will be. Our next equation is going to represent what happened on Tuesday. A total of $68 selling 5 adult and 2 child tickets. So 5X plus 2Y equals 68. When we solve this last equation by graphing, we will get an intersection point at 8, 14. So answering the question here, the X was how much the adult ticket cost. So that's 8. So adult tickets were $8. Child tickets were $14. And there we have it. We explored a little bit deeper with how systems of linear equations can be used to solve problems.